Several examples of functions have been discussed from the objective of finding domain range. Now, we want to have a greater variety to be included into that list. From that point of view, let me introduce this greatest integer function now. For any real number x, the greatest integer less than or equal to x will be denoted by this symbol x written within square brackets. Thus, we will have integer part 2.1 equal to 2, integer part 3.7 equal to 3. For any integer n, integer part itself, for the irrational number root 2, the integer part is 1. For the decimal 1.234, the integer part is 1. For the number pi, integer part is 3. For the negative number minus 0.1, the integer part is minus 1, not 0, because we want the fractional part to be always positive. Integer part may be positive, may be negative, may be 0, but fractional part should be always, I said positive, not positive, should be always non-negative. Fractional part I do not allow it to be negative. So, I will define the integer part to be minus 1, so that the fractional part becomes 0.9. Thus, integer part minus pi will not be minus 3, instead will be minus 4, so on. Let me try to draw a graph for this. I will obtain the graph, I may be obtaining the graph as follows. For numbers between 0 and 1, including 0, excluding 1, I find the integer part to be 0. This graph includes the point 0, but excludes the point 1. Next, for numbers between 1 and 2, I will be obtaining integer part as 1. This graph includes 1, but excludes the point 2. Similarly, between 2 and 3, I will be obtaining a line segment at a height of 2 units above the x-axis with left hand point included, right hand point excluded, so on. On the left side of the y-axis, for numbers between minus 1 and 0, we are getting integer part minus 1. Again, left hand point to be included, right hand point excluded. For numbers between minus 1, minus 2, integer part is minus 2, left hand point include, right hand point exclude, so on. Clearly, we find this x going to integer part x is a function with the domain entire set of real numbers. For any real number, we can find the integer part, and range, it does not include every real number, it includes only integers. So, our function is a function from R to Z and is defined by f of x equal to integer part x. Okay. Before taking up more illustrations involving integer part x, let me explore more on the meaning of the integer part x. Consider any number x. If the number is an integer, I find integer part x is equal to x. This is for x belonging to z. And if the number is not an integer, it involves fractional parts, then what will be the relation between integer part x and x? Always integer part x will be less than or equal to x. So, I have one important property: for any x, integer part x is less than or equal to x is less than integer part x plus 1. Again, consider any number x. We also have for any real number x, x minus 1 less than integer part x less than or equal to x. If x is an integer, I will have equality holding between these two, and if x is not an integer, inequality will be strict. The integer part will be a number strictly between x minus 1 and x. Relation holds good for every real number x. We also have few more interesting properties. Suppose x is an arbitrary real number and n is an integer. What will be integer part of x plus n? Very simple, easily seen, is just integer part x plus n for every n belonging to z and x belonging to r. Next, consider an arbitrary real number x. Together with x, I will have its negative taken, find the integer part x, add it to integer part minus x. What can be the sum of these two? Let us check. If x is an integer, integer part x will be itself, integer part minus x will be minus x itself, and therefore the sum will become 0. This if x is an integer. Suppose x is not an integer, x is some other real number, a real number involving some fractional part. Say example 2.1, this is 2, this is integer part minus 2.1, not minus 2, now it will be minus 3, and we get the sum equal to, instead of getting 0, we get it as minus 1, and this will apply for every number, real number other than integer. Okay. So, we have a very interesting nice function, integer part x, also called greatest integer function. Let us work more on this function now. Before taking up problems on domain range involving functions where integer part will be made use of, let me try some simple inequalities and equations involving integer part function. What is the meaning of integer part x equal to 1? X need not be equal to 1, x can have many more values. Meaning will be very simple, x must be a number between 1 and 2, 2 excluded, x in 1 included. What is the meaning of saying integer part x is some number between 1 and 3? Simply means x can be any real number between 1 and 4, 4 excluded, 1 included. What is the meaning of saying 1 is less than integer part x is less than 3? It means x must belong to integer part x can be only 2 now, therefore its value must be a number between 2 and 3, 3 excluded and 2 included. Similarly, the meaning of the inequality 1 less than or equal to integer part x less than 4 will be x must belong to interval left hand point 1, 1 included, right hand point 4 but not included. It can be any number strictly less than 4 like 3.9 or 3.99, so on. Okay. What happens if integer part of x is a negative number? Integer part x equal to minus 1. This means x can be any number between not minus 2 and minus 1. Now it will be a number between minus 1 and 0, minus 1 included, 0 excluded. Integer part x is some number between minus 1 and 2 means x can have any value from minus 1 included, to 2 excluded. having this much information about integer part, let me try one or two more involved algebraic equations now. Let us try to solve equations involving greatest integer function. As first illustration, let me consider the equation 2x cube minus integer part x equal to 7. No particular importance need be given to the coefficients of the number on the right hand side. I have randomly chosen the coefficients. Some equation, an algebraic equation, one term is integer part x. I need solve the equation. I need find what values of x satisfy this equation. A very simple job. Let me start with some trial and error procedure. What happens if x is equal to 0? Left side becomes 0 minus 0 equal to 0. The equation is not satisfied. Let me take up next possible value for x, not possible value, next integer value for x. I am just trying. I do not know when I am going to succeed. Left side now will be 2 into 1 cube minus integer part 1 is 1. Still it is less than what we are required to obtain, 7. Let me go to a higher value, say 2. Now the left hand side becomes 2 into 2 cube 16 minus integer part 2 is equal to 4. We have gone above what we are required to obtain. We have gone above the number in the right hand side 7, number obtained is 14. This suggests you your value of x or values of x satisfying the equation must be somewhere between 1 and 2. You take any value less than or equal to 1, what you are going to get will be less than 7. You take any number greater than or equal to 2, what you are going to get on the left hand side will be greater number, much greater number, because this increases at a faster rate and this increases at a slower rate. Even though this also increases, the rate at which this increases is slow, difference goes on increasing. Our solution must be somewhere between 1 and 2. Therefore, what can you guess now? Your solution must have integer part x equal to 1. Therefore, your equation is reduced to the only solution satisfying the equation is x equal to cube root 4. In the present equation, I have replaced our old x cube by x square. What happened as a result is, we have obtained here a function which is not continuously increasing. This is partly decreasing and partly increasing. Therefore, we will have this equation satisfied not over just one interval. There is a likelihood of getting two intervals, separate intervals, over which the equation will have solutions. To avoid the job of guessing those two intervals, let me follow a totally different approach, a more logical approach. No guesses will be involved now. What I do is, suppose you rewrite this equation as integer part x equal to 2x square minus 7. Use one of the properties of integer part x. I am using this property, x minus 1 less than or equal to integer part less than or equal to x, which holds for every x belonging to R. If you apply this, you will notice x minus 1 must be less than 2x square minus 7 must be less than or equal to x. If any x satisfies the equation, it must satisfy each of the two inequalities contained here. Let me handle the inequalities individually. The first part, this means 2x square minus x minus 6 greater than 0, that is factorizing 2x minus 3 into x minus 2x plus 3 into x minus 2 greater than 0, which means x must lie outside the interval minus 3 by 2, excluding minus 3 by 2, also excluding 2, Let me write it symbolically. It does not belong to the interval, it lies outside, so I will represent it this way. This means, according to me, this means x lies outside, excluding minus 3 by 2, excluding 2. Okay. Now let me consider the next part of the inequality, that is 2x square minus 7 less than or equal to x, which means 2x square minus x minus 7 less than or equal to 0. I want a quadratic with the x square coefficient positive to be less than or equal to 0. This happens when x lies between the roots of the equation. What are the roots? Minus b plus 1, b is minus 1, minus root b square minus 4ac, 1 minus 4 into 2 into minus 7, 1 minus minus 56, 57 by 2a 4 less than or equal to other root minus b plus root b square minus 4ac divided by 2a 4. Roughly, this is 1 minus root 57 is 7.5 so on, is between 49 and 64, and closer to 64 is away from 49. I may guess a value to be roughly 7.5 something. 1 minus 7.5 something minus 6.5 something divided by 4, roughly minus 1.5 something. This side 7.5 something plus 1 divided by 4 roughly is 2.1 so on, something extra to be added. In order that x may satisfy this equation, x must satisfy both these inequalities. So, x must satisfy this condition as well as this condition. So, we conclude x must be a number which either lies between 1 minus root 57 by 4 and minus 3 by 2, minus 3 by 2 excluded, minus 1 minus root 57 by 4 included, or must be a number between 2 and this 2.1 something, that is interval 2 to 1 plus root 57 by 4, 2 excluded, 1 plus root 57 by 4 included. If x belongs to this interval, only one possibility, integer part x will be equal to minus 2. And if x belongs to this interval, only one possibility, integer part x must be equal to 2. Therefore, we conclude integer part x can have only one of the two values, either minus 2 or plus 2. Let us deal with the values individually. If integer part x is minus 2, my equation implies 2x square equal to 5, x square equal to 5 by 2. Therefore, one possible value for x will be minus square root of 5 by 2. Why only minus square root of 5 by 2? Even though the number has two square roots, I can't accept the positive square root, because I have obtained the equation using this assumption, integer part equal to minus 2. The value you have obtained here, is it a number with integer part equal to minus 2 as desired? Yes, 5 by 2 is 2.5, root of that will be 1 point something, and the x value will be minus 1 point something. Yes, indeed, its integer part will be minus 2. This is one of the solutions of the equation. There may exist more solutions. Let us consider the other possible value for integer part x. If we use the other value, we will be getting 2x square equal to 9, x square equal to 9 by 2. Therefore, one more possible solution for the equation is x is equal to root of 9 by 2 or 3 by square root of 2. Does this number have the integer part equal to plus 2 as desired? Yes, it has. Therefore, we are getting two solutions for our equation. One is this, another is this. Okay. One more equation of the same type, but with different kind of solution set. Say 3x square minus 5 into integer part x equal to 4. I want to know what are the solutions of the equation, what are the different x values that may satisfy the equation. Okay, same procedure I will be once again repeating. This means integer part x must be 3x square minus 4 divided by 5. Applying one of the properties of integer part x, I conclude x minus 1 must be less than 3x square minus 4 divided by 5, less than or equal to x, or 5x minus 5 less than 3x square minus 4 less than or equal to 5x. We have a set of two inequalities. Let us handle the inequalities individually. Consider this part of the inequality. This means 3x square minus 5x plus 1 greater than 0. Consider the quadratic. Is this a factorizable quadratic? Discriminant is b square 25 minus 4ac 4 into 3 12. 25 minus 12 is not a perfect square, not factorizable. Let me find the roots. Claim that in order to have the expression positive, x must lie outside the roots. What are the roots of the equation? Minus b plus or minus lower root minus upper root plus root of b square minus 4ac 25 minus 12 13 divided by 2a 6 plus root 13 divided by 2a 6. X must lie outside the root. Excluding the actual values of these numbers means x belongs to the exterior of the interval. Agreed? Roughly, what is value of this expression? Root 13 is roughly 3 point something. 5 minus 3 point something is 1 point something. Divided by 6 is 0 point something. I do not know whether more accuracy is needed. For the moment, let me have it as 0 point something. This is 5 plus 3 point something, 8 point something is 1 point something. Let me have the numbers like this. Now, the other part of the inequality, 3x square minus 5x minus 4 less than or equal to 0. At least, is this quadratic factorizable? B square is 25 minus 4ac 4 into 3 into 4 into 3 12 into 4 48 with the negative sign. 25 plus 48, no, not a perfect square. Again, I have to depend on roots of the equation. My claim will be x must be a number between the roots minus b minus or plus root of b square 25 4ac 4 into 3 12 into minus 4 minus 48 25 minus minus 48 25 plus 48 48 plus 25 68 73 divided by 2a 6, the other root 5 plus root 73 divided by 6, x must lie between the roots. Roughly, this is 8 point something, 5 minus 8 point something minus 3 point something divided by 6 minus 0.5 something. Agreeable? And on this side I am having 8 point something plus 5, 13 point something divided by 6 is 2 point something. Okay. My x is to this side of 0 point something and to this side of minus 0.5 something. Therefore, one possibility integer part x is equal to minus 1. X is to the left of 0 point something okay, this is 0 point something, not 0, the value is actually slightly more than 0, and this is definitely a number greater than -1 but less than 0. So, I have two possibilities. Number may be between this number and 0 having integer part -1, or it may be on this side of 0, that is between 0 and 0 point this small number, in which case the integer part will be 0. Two possibilities. Next, on this side, x is a number which is greater than 1 point something, not 1, it is greater than 1 and must be less than or equal to 2 point something. So, again two possibilities, it may be between 1 point something and 2 having integer part 1, or maybe between 2 and 2 point something integer part 2. So, total we have 4 possibilities, integer part may be -1, 0 or 1 or 2. Okay. One by one. Suppose integer part is -1, the equation becomes 3x square equal to -1. X cannot be real, x is non-real, you will not get any real root for the equation. Okay, reject it. Next possibility, integer part 0, 3x square equal to 4, x square equal to 4 by 3, roughly 1 point something, x is equal to negative root, I need not consider, positive root 1 point something. Will it have integer part equal to 0? No. Again we have a reason to reject this value. Next possibility, integer part x equal to 1, equation will become 9, 3x square equal to 9. So, x square equal to 3. So, x is equal to 1 point something with the integer part 1. Does it satisfy this requirement? Yes. One solution for my equation is x equal to root 3. For x equal to root 3, this is 3, 3 into 3 9, minus 5 into integer part 1, it agrees, satisfies the equation. One more verification. Last possible value, integer part 2. Equation will be 3x square equal to 4 plus 10, 14, x square equal to 14 by 3, roughly 4 point something, x will be positive square root of 4 point something is 2 point something. Will you get the integer part as desired equal to 2? Yes. We get one more solution for the equation, that solution being square root of this number, root of 14 by 3. Our equation has two roots, one plus root 3, other plus root 14 by 3. Ours is a equation with exactly two real roots. Next, let me get back to the job of finding domain, codomain of known functions. Now, the functions will involve greatest integer function, that will be the only difference. Let me consider, say 2x, integer part 2x, domain is the entire set of reals, range, will it be the entire set of integers or will there be any difference because of the inclusion of this coefficient 2x? No, there will not be. Individual function values may change, value of the function at x equal to 1 may change, value of the function at x equal to half may now be different from value of integer part x, but when you consider the set of all image elements, when you consider the range, you won't find any difference. Domain is the entire set of reals, range is the entire set of integers. Suppose I consider this now, no change, you can easily see that. Again, domain and range will be r and z as before. Suppose you consider x by 2 integer part, again no change, it is defined on the entire set of reals, will have as range the set of all integers. Suppose you consider the integer part of now a quadratic term x square. You know this x square cannot be negative, is always greater than or equal to 0. Therefore, now the integer part cannot attain any negative integral value. So, the only values attainable by this will be the collection of non-negative integers including 0, 0, 1, 2, 3 so on, or it is set of all natural numbers together with the integer 0. This will be the range, and domain as before, no change, set of all reals. Instead of dealing with such a simple quadratic, how about considering a more involved quadratic, say x square plus x plus 1 now. X square plus x plus 1, suppose you consider the graph of the function. You know the graph will be a parabola. Because x square coefficient is positive, a parabola with vertex below, the vertex will have x coordinate minus b by 2a, y coordinate when x equal to minus half, x square is 1 by 4, 1 by 4 minus half plus 1, 3 by 4. So, the values attained by x square plus x plus 1 is the set of all numbers greater than or equal to 3 by 4 including 3 by 4. So, the values attainable by this integer part function will be the integer parts of functions greater than or equal to 3 by 4. What will that be? It will be again the set of all natural numbers together with the integer 0 is the range, domain as before, the set of all real numbers. Next, let me consider integer part of square root of a quadratic. First, let the quadratic have x square coefficient positive. Say this one, we will consider integer part of square root of x square minus 2x plus 3. Will the domain now also be same as the domain of the previously considered functions? No, no guarantee. We need examine this more closely now. The square root of a number need not be always meaningful as a real number. It will be meaningful only if the number under the radical sign is greater than or equal to 0. Let me check by considering graph of the function, my usual approach. For the function x square minus 2x plus 3, a quadratic with x square coefficient positive, graph will be a parabola with vertex below. For the vertex of the parabola, the x coordinate will be minus b by 2a plus 2 by 2a 1, and y coordinate when x equal to 1, 1 plus 3 4 minus 2 2. This means graph lies completely above the point 1 2. This expression takes only values greater than or equal to 2. Will the square root be always meaningful? Yes, no problem. Domain is the entire set of real numbers. What about the range? Expression x square minus 2x plus 3 lies above 2. Therefore, the square root will lie above root 2. Values this expression takes will be always greater than or equal to root 2. Therefore, integer parts will be greater than or equal to integer part of root 2, that is 1, will be integer set of all integers greater than or equal to 1 is precisely the set of all natural numbers. Okay. Some more variations in the same case. Next, why not consider a quadratic again with x square coefficient positive, but not lying wholly above the x axis, lying only partly above and partly below. How do we get it? Root of, I want my quadratic now to have x square coefficient positive, and I want the vertex to lie partly below. Let me have a negative number here. Let me check what happens. Consider a negative number with considerably large magnitude. I will take up here minus 2x, say minus 7. Let me find out. x square coefficient positive. So, for the function x square minus 2x minus 7, graph will be a parabola, vertex below. The vertex will have x coordinate minus b by 2a 1, and when x equal to 1, y coordinate 1 square minus 2 into 1 minus 7, 1 minus 9 is minus 6. As I demanded, my parabola will be having as vertex a point lying below the x-axis. X-axis is somewhere here. Will the function be meaningful for every real value of x? No. For points below the x-axis, the y coordinates are negative. A value taken by the quadratic x square minus 2x minus 7 are negative. Square root will be undefined. Integer part also not obtainable. Function will be meaningful only for points above the x-axis. What are these points? These are the points where the line crosses the x-axis. Line crosses the x-axis means y coordinate equal to 0, means x square minus 2x minus 7 equal to 0. Where is x square minus 2x minus 7 equal to 0? Can you factorize the expression? What is b square minus 4ac? 4 minus 4 into minus 7 minus 28, 32 is not a perfect square. Exact values of the square root, values of the roots of the equation are 2 minus b 2 minus root b square 4 minus 4ac minus 28, 32 divided by 2a 2. The other root is 2 plus root 32 by 2. Or I can slightly simplify. This is 1 minus root 8 and this is 1 plus root 8. My function is meaningful only for x outside this interval. The domain of my function will be the interval, union of the intervals, minus infinity to 1 minus 2 root 2, interval closed at to 1 minus 2 root 2, union. The other part 1 plus 2 root 2 to infinity, again interval closed at 1 plus 2 root. This will be the domain of our new function. What will be the range? Range is nothing but set of all values taken by the function. The function x square minus 2x minus 7 takes all values from 0 to infinity, including 0. Therefore, square root takes all values from 0 to infinity, including 0. Therefore, integer part takes all integral values from 0 to infinity, including 0. What is that set? Integers 0, 1, 2, 3, so on, or I may write it as, describe it as set of all set of all natural numbers together with the only integer which is neither positive nor negative, the integer 0, n union 0 will be the range for this new function. One more example. Let me have next x square coefficient negative. Let me consider a parabola with vertex above. What happens? Okay, let us have this example. Because the quadratic 3 plus 2x minus x square has x square coefficient negative, graph will be a parabola with vertex above. The vertex will have x coordinate minus b by 2a, minus b is 2 divided by 2a minus 2, minus 2 by minus 2 1, and y coordinate when x equal to 1, 3 plus 2 minus 1, 5 minus 1, 4. Does the point lie above the x-axis? Yes. This is the position of the x-axis. Okay. My function attains positive values at some points, negative values, not my function. The function x square minus 2x minus 7, only that portion, attains positive values at some points, 0 at 2 points, negative values at some other points. Square root will be meaningful only when values attained are greater than or equal to 0. So, domain will be the set of all numbers between these 2 points. What are these points? These are the points where the graph of 3 plus 2x minus x square crosses the x-axis, or x square minus 2x minus 3 equal to 0, or x minus 3 into x plus 1 equal to 0. Am I right in factorization? Yes, I think. Values are, one is minus 1, another is 3. Domain is the finite interval minus 1 to 3 with both endpoints included, closed interval minus 1 to 3. What about the range? The part x square minus 2x minus 7, it is clear from the graph, takes values as long as x lies between minus 1 and 3, takes values between 0 and 4, 4 including. Therefore, square root of the quadratic 3 plus 2x minus x square will take values between 0 and 2, including 2. Therefore, integer part will be integer part of numbers between 0 and 2, including 2, including 0. The set will consist of only few elements. The elements are 0, 1 and 2. It is a 3 element set. Range becomes a finite 3 element set. Domain becomes a finite interval, closed interval minus 1 to 3. The next function I am going to consider will be integer part of sin x. For what values of x, sin x is determinable? For any real value. What value you get as value of sin x? A real number between minus 1 and 1. For any such number, can you find the integer part? Yes, no problem. Domain will be set of all reals. What about the range? You already noticed sin x takes values between minus 1 and 1 only, including minus 1 and 1. So, what are the possible values for integer part? It cannot be 2, it cannot be minus 2. Only values it can take are minus 1, 0 and 1. Range is a 3 element set, domain is the entire set of real numbers. Let me try slightly more complicating the expression appearing here as argument of sin of say x square plus x plus 1. The argument of the function sin here is x square plus x plus 1, a quadratic with the x square coefficient positive. So, we will have as graph a parabola with vertex below, the x coordinate of the vertex being minus half minus b by 2a and y coordinate minus 1 by 4 minus half plus 1 is 3 by 4. So, only values greater than or equal to 3 by 4 are attained by x square plus x plus 1. Still, when all values greater than or equal to 3 by 4 are covered by x square plus x plus 1, the entire set of 4 quadrants will get covered. At least once will get covered. Starting point now may not be 0, starting point is 3 by 4. By 3 by 4, I do not mean 3 by 4 degrees, I mean 3 by 4 radians somewhere here, does not matter. All values greater than 3 by 4 are covered, and every value greater than 3 by 4 is covered by this function, means every quadrant is covered, not once, many more times, infinite number of times. Because all quadrants are covered, the value of the function sin of x square plus x plus 1 will cover all values from minus 1 to 1, and therefore, will have integer part defined at every point. Domain is the set of all real numbers and range is the set of all integers integers between minus 1 and 1, the integers minus 1, 0 and 1. Next, let me consider one other special function, the fractional part of x. We may define this by, for any real number x, we define this fractional part x to be simply actual value of x minus its integer part. Clearly, this will be obtained as a number between 0 and 1, 0 included, 1 excluded. For example, not only for 1, for any integer, the fractional part is 0. Fractional part is 0.1. Fractional part is 0.5. Sorry. Fractional part is not minus 0.1 is 0.9 because integer part is 3 and actual value minus integer part minus 2.1 minus 3 becomes 0.9. Even otherwise, you must treat this as a negative integer part plus a positive fraction and read that positive fraction as the fractional part. Okay. Fractional part root 2 is 0.14 is only an approximation. I want the exact value. Okay. Root 2 minus 1 by definition actual value minus integer part. Fractional part pi will be pi minus 3, fractional part minus root 2 will be, again apply the definition, actual value minus root 2 minus its integer part minus 2. Final value must be a positive number. Okay. What we notice is for any integer n, the fractional part is 0. So, in particular, for the integer part of any number, the fractional part is 0. What about integer part of fractional part of a number? This is always a fraction between 0 and 1, 0 included, 1 excluded, therefore integer part is 0. What is fractional part of a number? Because this is a positive fraction between 0 and 1, its fractional part will be itself. Suppose x is any number, any arbitrarily chosen real number, what will be the sum of the fractional part of x and the fractional part of minus x? Consider some examples. Suppose this number is 2.1, fractional part is 0.1. This number will be minus 2.1, fractional part will be 0.9. What is the sum now? 1. One possible value is 1. Next, suppose that x is an integer, whole number. Fractional part is 0. Minus x will be another whole number, minus 2. What is the fractional part? Again 0. Now the sum becomes 0. The sum is 0 if x is an integer. Otherwise, if x does not belong to z, for any other number, a non-integer number, the sum will be equal to 1. Next, let us consider the graph of the function. Graph of the function y equal to fractional part x. We find that the function is very well defined. It is a function with domain equal to the entire set of real numbers R. If the number is between 0 and 1, number itself will be a positive fraction. Therefore, the function value will be x itself, the argument itself. Therefore, the graph will be line segment of the line making 45 degrees with the x axis passing through origin, with this point included. Fractional part 0 is 0, fractional part 1 is not 1, 0, this point excluded. Suppose next x is a number between 1 and 2. For a number between 1 and 2, integer part is 1. So, the fractional part will be actual value of x minus 1. The function formula now becomes y equal to x minus 1. again part of a line segment of line having slope 1, making 45 degrees with the x axis, now not passing through origin, y equal to x minus 1, when x equal to 0, y equal to minus 1, when y equal to 0, x equal to 1. Am I right? Yes, the graph will be like this, parallel to this segment, again 1 included, 2 excluded, point above 2 excluded. For numbers between 2 and 3, so graph will look like this. It is clear from the graph, range for the function is the set of all numbers between 0 and 1, 0 included, 1 excluded. Domain, set of all real numbers from minus infinity to infinity. Range is the set of numbers between 0 and 1, 0 included, 1 excluded. What does this inequality mean? Is fractional part x always a number less than half? No. There are many instances where fractional part x will not be less than half. So, only certain select real numbers will satisfy this inequality. What are those real numbers satisfying the inequality fractional part x less than half? Clearly, numbers satisfying this are numbers between 0 and half, 0 included, half excluded, union, certain numbers between 1 and 2. Which numbers? Numbers between 1 and 3 by 2, 1 included, 3 by 2 excluded. Certain numbers between 2 and 3, numbers between 2 and 5 by 2, 5 by 2 excluded, 2 included. And on this side of 0, among numbers between minus 1 and 0, those numbers which lie between minus 1 and minus half excluded, minus 1 included. Among numbers between minus 2 and minus 1, those numbers between minus 2 and minus 3 by 2, minus 3 by 2 excluded, minus 2 included, so on. Or I can abbreviate the whole expression by the expression union number of closed intervals, number of intervals closed at left hand point, open at right hand point. What is a general expression for these left hand end points? N, where n can be any integer. What is a general expression for right hand point of the interval with left hand point n is n plus half. Union of all intervals of the form n to n by 2, n included, n plus half, n to n plus half, n included, n plus half excluded, where n runs over all integral values n belonging to set. This infinite union is going to be the solution set of the inequality fractional part x less than half. Next, let me try one equation. Try solving an equation involving fractional part. Let me include even integer part function in it. The equation I am going to consider will be mod of say 2 minus 3x equal to 2 into integer part x plus 3 into fractional part x. I want to get this equation solved. Equation involves 3 special functions: modulus, integer part and fractional part, all the 3. What do I do? Because involvement of more special functions complicates the procedure involved in solving the equation, I must aim at reducing the number of special functions belonging to the equation. First, I tackle the simplest of the 3 functions, the fractional part. I have a regular relationship between fractional part and integer part. With the help of that, let me remove this and replace this by an expression involving integer part only. Okay, using that relationship between fractional part and integer part, I get the equation rewritten as mod 2 minus 3x equal to 2 into integer part x plus 3 into x minus integer part x. Or my equation becomes 2 into integer part minus 3 into integer part minus integer part x plus 3x. Now, usual procedure, you are required to solve an equation involving integer part. Method will be isolate this integer part, apply the conditions. Integer part always lies between x minus 1 and x, including x, excluding x minus 1. Try to obtain some restrictions on possible values of integer part. There is a modulus here. We will try to get rid of that later, considering two sub cases. The equation first will be written as integer part x equal to 3x minus modulus of 2 minus 3x. Because for every x, integer part x lies between x minus 1 and x, we get 3x minus mod of 2 minus 3x is a number between x minus 1 and x minus 1 excluded, x included. Or this means, consider the two possibilities separately. If 2 minus 3x is greater than or equal to 0, that is if x is less than or equal to 2 by 3, inequality will mean x minus 1 less than 3x minus 2 plus 3x less than or equal to x. Because modulus 2 minus 3x is itself now. That is, what does this mean? 6x minus x, 5x greater than 1, and what does this part mean? 6x minus x, 5x less than or equal to 2. That means x is greater than 1 by 5 and less than or equal to 2 by 5. Means integer part x must be equal to 0. You have assumed here x is less than or equal to 2 by 3. When x is a number less than or equal to 2 by 3, is it possible to get integer part x equal to 0? Yes, we can. Clubbing the two, we find x must be a number between, in order to have integer part 0, it must be a number between 0 and 1. In order that this may be satisfied, the x value must be a number between 0 and 2 by 3, 2 by 3 included, 0 also included. In any case, integer part x will be 0. Substituting in our equation, we will be getting, where is our equation? Here is our reduced form of our equation. X is a number between 0 and 2 by 3. This part is 0. This part is 2 minus 3x. 2 minus 3x equal to 3x means 2 equal to 6x or x equal to 1 by 3. Is 1 by 3 a number satisfying these two conditions? Yes, we successfully got one of the solutions of the equation x equal to 1 by 3. Now the other possibility, 2 minus 3x negative. If 2 minus 3x is negative, our equation will read x minus 1 less than, not equation, this condition will read x minus 1 less than 3x minus modulus of 2 minus 3x now is 3x minus 2, and this must be less than or equal to x. This means 3x cancel, x minus 1 less than minus of minus 2 less than or equal to x. That is, x must be less than 3 and x must be greater than or equal to 2. X is greater than or equal to 2, less than 3. Can we have 2 minus 3x less than 0? 2 minus 3x less than 0 means 2 less than 3x means x greater than 2 by 3. Can x be 2 by greater than 2 by 3 when x is between 2 and 3? Yes, every number between 2 and 3 satisfies this, and a number satisfying these inequalities will have integer part 2. Substituting in this equation, this is 2 now, this is 3x minus 2. 3x minus 2 is equal to 3x minus 2. What you got is an identity, means what? Equation is always satisfied. Every number that lies between 2 and 3 satisfies this, satisfies our requirements, also our equation. Every number between 2 and 3 is a solution. Therefore, the final solution set will be singleton 1 by 3 union set of all numbers between 2 and 3, 2 included, 3 excluded. This infinite set is the solution set for our equation.